Seeing what makes us tick. Ski 626. Scientists getting their kicks. With deadly disease, can do what it please. Results that are hard to predict. Ski 626. Push the side right quick. With brothers you dig, again pigs for vicious experiments. Good afternoon, everybody. We opened up with some Gil Scott because we felt it was appropriate today based on what we're seeing in the news. We'd like to keep everybody up to speed with what's happening with the vaccines and what is happening with testing as well as contract tracing. We have some great slides today, so we're going to jump right to it really fast to be as succinct as possible. So, Dr. Solomon, can you post the first slide? So the title of today's conversation is Vaccines, Testing, and T-cell Immunity. And it says, don't overlook the T for the vax. Here's the facts. All right. What I mean by that is that there is specific T-cell immunity that's being overlooked. And I'd like to go into the discussion here, so you can go to the discussion slide. On the discussion slide, we'll talk about PCR testing versus antibody testing. We don't want to limit our information about memory T cells and memory B cells. That's very important. That in the media today, there's not enough conversation about that. There's an over-reliance on the vaccines without considering other factors that play in our immune systems and in our natural immune systems. Then there's also inaccurate PCR tests that play a role in the data that come in from vaccine trials, as well as the data that comes in as far as who has COVID, who doesn't have COVID. Additionally, we'll talk about the vaccines that are going to be coming available very, very soon, which don't involve messenger RNA vaccines, which I term here as nucleic acid vaccines. And we have also viral vector vaccines, which is Johnson & Johnson, AstraZeneca, and inactivated viruses. The point is to not settle. We don't want to settle for the messenger RNA vaccine. So next slide. Okay, so the first thing that I want to say is that there are enormous flaws in the testing. Now, when we look at the testing that was done for the Pfizer and Moderna vaccines, we have to keep in mind that testing, when COVID came out about a year ago, about a year and maybe 2 months ago, there was a scramble to develop testing to determine who has COVID or not. And during that period of time, the FDA was approving almost anything. And there were no sort of validation studies on any of the tests. And a lot of those tests have been thrown out. As a matter of fact, as we posted here, out of 281 companies that had testing that were approved at one time for PCR and antibody testing, 269 have been removed from emergency use authorization. 269 of the 281 tests. So that means that around 16 tests are available that are up to speed, that are validated, that meet the standards for emergency authorization by the FDA. So keep that in mind. So when we look at the flaws in testing, we have to ask the question about the Pfizer and Moderna trials in the beginning, when they were saying they were 94 or 95% effective. You have to wonder, were they indeed effective, or were the tests involved with testing whether patients had the disease or not was flawed as well? And then we'll also go into asymptomatic COVID as we go along in our slides. So next slide, please. Okay, so we find some very good information out of a well-established, peer-reviewed journal called Cell. And Cell produced some very interesting information. And with that information, based on a study, it was determined that the researchers were looking at people that did not have COVID. They were just donors at one time in 2015, where COVID-19 hadn't even come out yet. And they were obviously probably exposed to COVID one, or what I should say, or the first coronavirus one, and not coronavirus two. And in being exposed to that virus, they mounted some T cell response. And when we looked at the T cell response based on the data, we were floored to find out that 40 to 60% of old samples of T cells recognize SARS-2. So, what that means is that T cells can last for years. Whereas when we look at the propaganda that is being spewed on social media, on mass media, on corporate sponsored media, there is an over reliance on the vaccines that are coming out to solve our problems. Whereas we have natural immunities that have been developed in all of us that could play a part and play a role that we are not considering. So, next slide. Okay, with the next slide, I wanted to give an idea as far as how viruses and the hosts and T cells work. So, when we looked at the fact that there are 40% of patients that are asymptomatic, and it is estimated around 40% of COVID patients, the people that contract COVID, are asymptomatic. They don't feel anything at all. They go about their normal lives. And the reason why that could be happening is that from this diagram, you have virus, which could have genetics playing a part. The genetic makeup of the virus could be weaker or stronger. The amount of the virus, meaning you can have more viral load, meaning if someone with COVID sneezed directly in your face, you would have a heavy viral load as opposed to having a mask on and someone talking, and you get a small trigger from the virus. So the viral load would be smaller. And with the host meaning the person that contracts the virus, their age plays a factor. We know that T cells and the innate immune response is much slower in elderly people or older people. And the older you get, the innate immune system, which is the trigger for your response in general for your body, it's the initial response that happens when you directly contract the virus. That is much slower as you get older, and then your health condition plays a role, and then genetics, the genetics of your T cells, your B cells, and how you respond to viruses play a role in whether you are asymptomatic or not. And then when you look at the immune system, we're talking about the virus first goes to the T cells, then the T cells warn the B cells to respond and make plasma cells, which makes antibodies. So that's an oversimplification of the immune system, but that's pretty much the route that it takes. The macrophages engulf the virus. The macrophages display major histocompatibility markers. The T cells come and read that. The T cells send, or the helper T cells send the response to the B cells. The B cells present and make plasma cells that make antibodies. Okay, so that's the central dogma of immunity. So if you look at that, you can see that a T cell response is first. And if the T cells response is first, and we're always only looking at antibodies when we talk about vaccines, vaccines are to mount an immune response, and you want to have more antibodies in your system. But we're not considering the aspect of T cells. And T cells, as we can see from the article in Cell, play a major role in our immunity. And as you can look at the bottom of the page, you can see that post-COVID patients, we have post-COVID patients, we have patients that we looked that were pre-SARS, pre-COVID too, and you can see that that was 2015, 2018. They were mounting a cross reactivity. They were responding to COVID 19, even though they had never even seen COVID 19. Okay, next slide. Okay, so in this slide, we talk about the partial immunity effect. And when we look at that, we say that the CDC even estimates, as I said before, 40% of COVID 19 cases are asymptomatic. This is evident in three places, but on another slide, we'll show you more. But in a Boston homeless shelter, we found that out of 147 patients that were that contracted the COVID virus, 88% were asymptomatic. And we looked at Tyson Foods where there were 481 infections and 95% were asymptomatic. And then we looked at prisons and we actually looked at the a conglomeration of certain prisons in Arkansas, North Carolina, Ohio, and Virginia, and it amounted to 3,277 infected people. And out of those people, 96% were asymptomatic. So let's go to the next one. Okay, asymptomatic novel coronavirus. So here's another list of other places that were reviewed, and we looked at the percentage of people that were asymptomatic and the amounts of people that were tested, and we found some striking similarities between all these places. And eventually, you could look at these slides. We'll provide the slides, but you can see that all of these places had additional asymptomatic patients in quite a few, in high percentages. Next slide. Okay, this slide he talks about PCR versus immune response testing. And when I say immune response testing, I'm talking about antibody testing. So with PCR testing, you're looking at the genetic makeup of the virus itself. And so when you sneeze or cough or you contract the virus, it goes into the respiratory tract. And it's easy to utilize a swab to go through your nose or through your mouth to the throat to determine the viral load within the swab that is being taken as a sample. And when you take the viral load, when you scrape it and you see whether virus is there, you can determine whether the genes of the virus are there, and you amplify that, and you can determine whether a person has COVID or not. This is quicker because you can determine that within 2 days of a person having symptoms. And with antibody testing, it takes 6 to 7 days after symptom onset. So you can see why antibody testing is not as readily available or readily used, because it's not as effective in determining whether you have COVID or not initially. So that's very important to say. The other thing to say is that generally speaking, viral shedding is undetectable 21 to 35 days after symptoms onset, or 3 to 5 days after the patient becomes asymptomatic. So that's very important to kind of keep that in mind. 21 to 35 days after symptom onset. So it's very important to know that there's a difference between PCR testing versus antibody testing. The thing that I like to say about antibody testing, though, is that there are two specific, what we call isotypes of antibodies that we look for that can tell whether you have contracted COVID in the past or whether you have COVID currently. And one would be the IgM test. The IgM test is less robust as far as the longer periods of time that it would last, but it's one of the more initial responses. And that one is one that will tell whether you have COVID recently. And then the IgG test will test whether you've had COVID in the past. So the point of a lot of what we're saying today is that we are not considering whether a patient has had, or the population has had COVID in the past. And we continually say that people should have vaccines, and we're not against vaccines, but we're not paying attention enough to the people that have already mounted an immune response through their T cell response, their B cells that produce antibodies, through their natural way of mounting an immune response. And that's not being factored. We even go as far as to say that the government is now asking and suggesting that there will be vaccine passports. And this we find to be problematic without considering that patients and people, populations of people, have been exposed to the virus already. They've already mounted an immune response the same as what they would amount if they have given the vaccine, yet that is not being considered in the so-called passport. That a person that has had COVID, that has mounted an immune response, is not being counted as having an immune response, and we find that to be problematic. Another thing to say about that, if you look at the mathematics of it all, there are around 31.8 million people that have contracted the COVID virus so far. And when you look at the R naught, that's meaning the infectability rate of COVID, which is every one person affects three people. If you look at that alone, and you also look at the tests that have been grossly inaccurate, as you can see in the other slide, where 269 of the companies have been thrown out. When you look at that, you can say that out of 31.8 million people, you could triple that number and take that up to around 94 million people. Today, it was counted as today that 200 million vaccines have been delivered to the American population. So when you look at that, and there's only 300 million people, over 300 million people in the United States, that means that we probably already reached herd immunity, and that we should begin to examine antibodies and T cells along with providing vaccine when necessary to the patient population. So that's one of the take home points for this conversation. So next slide. Okay, so this slide we found to be important because we look at the deceptive nature of the clinical trials and we look at the flaws. So I want to say this briefly, but when you look at this Moderna, when you see zero here, the Moderna vaccine was given on this day zero, and it was given at day 28. And then patients were asked 14 days to come in if they were symptomatic. 14 days later, they never looked at anybody that was asymptomatic. And so those people may have contracted COVID. And you know that 40%, we've already determined that, even the CDC has determined that 40% people are asymptomatic. Additionally, the tests were grossly flawed at that time. So when we look at the value of the numbers to say that the drug was 94% effective is a bit misguiding, and we'd like to point that out. And we'd like to point that out for Pfizer as well. On the next slide, Pfizer is very similar. The patients came in on day zero, and then on day 21 they had another vaccine, the second round, and in 7 days they were to report whether they had symptoms or not. They didn't report whether they were asymptomatic or not. And again, with flawed tests, you cannot say that the vaccine was as effective as what you're saying, what the news is reporting. So next slide. Okay, with AstraZeneca, it was a very interesting test as well. Same as day zero, come back the next 28 days, get another dose, and then 14 days later, they did at least give patients a PCR test. We found that to be a better way of determining whether the compound was working or not, and their data can be termed as more accurate. But as you can see, the efficacy was lower, which is probably what Moderna and Pfizer were as well. Next slide. Okay, so this brings me to the rare blood clots that are seen with J&J. And you know, on the Dirty Beaker, we mentioned uh, J&J vaccine and that we were more comfortable with the technology of the J&J vaccine because it was a little bit more tried and true, because they were using, at least they were using the adenovirus of a human being, and it was only one shot, and we recommended, we said that if one was to take a vaccine out of the three that were coming in the United States, that we would suggest that one as opposed to the messenger RNA vaccines from Moderna and Pfizer, and the DNA vaccine coming out of AstraZeneca, which uses a chimpanzee adenovirus vector. With that said, we felt it was important to talk about what is going on with J&J. And when we go into what is going on with J&J, yes, out of 6 million people that have received the vaccine from J&J, there were 6 patients that had these rare clots. The ladies were between 18 and 45 years of age, and they were all women. And so there has been a pause in J&J, as you have seen in the news. We have this diagram here to kind of give you an example of how and what happens with these clots. Apparently, when you have a clot, the clot can lodge anywhere in any parts of your body, but it can travel up through the inferior vena cava, which is down here at the bottom with this red marker here, and it can enter into the brain. And as you can see, there are major sagittal sinus within the brain that you can see, one at the top, which is superior sagittal sinus. You see in the middle is the inferior sagittal sinus, and then you see at the bottom where you see the transverse or straight sagittal sinus, and then it goes down to the transverse. The Because of gravity, the clot travels down to the transverse sinus, and it could create a clot. And the difference between this clot and most clots that occur is that there is a low platelet level, and we found that to be extremely odd in the medical profession, and it makes it very difficult to treat because normally you want to treat a clot with heparin, but heparin is contraindicated in this sense, so it made it very scary for us to begin to treat patients. Again, this was rare, but it's definitely something to look out for. And as we said before, with these vaccines, there has not been a lot of long term safety on them. And that's one reason why we sort of warned against them and recommended socially distancing and doing what is necessary to keep yourself from contracting COVID rather than taking a vaccine until we get some that are better suited for the human population, that have been tried and true science. And we'll talk about a little bit more of that on other slides. We also want to say with the J&J vaccine, and I think Dr. Solomon, the next slide goes into, yes. So when we look at the J&J vaccine and how in the media it has been reported that there have been these 6 cases of these cerebral vascular thrombi. And when you look at that, you look at the mysterious nature of what happened in Pfizer with Dr. Gregory Michael. Now, Dr. Gregory Michael was a 56-year-old physician. He was very healthy, and he took the Pfizer vaccine. And on the second day, on the second dose of the vaccine, 16 days after receiving it, he developed a severe blood disorder. And this blood disorder turned into acute immune thrombocytopenia, which caused his brain to bleed. So it's a very, very serious incident with the Pfizer vaccine. Now, what is strange about this, what is mysterious about it, is that the coroner, we've been waiting to hear the report from this. The coroner comes back and says that Dr. Gregory Michael died of natural causes. Now, there was a lady in North Carolina. Her name is Miss Hester. She just died. She was 116 years old. She went to sleep and she died in her bed. We call that a natural cause. She was 116 years old. But when you look at a man that's 56 years old and was very healthy and just took the COVID vaccine, for a coroner to say that this man died from natural causes when he had a bleed to the brain, he had petechiae that was overwhelming on his body, meaning these really bloody red spots all over his body. Yet the coroner says he dies of natural causes. And we find this very, very suspicious and mysterious. And we say that Yes, Johnson and Johnson is reporting their serious adverse events, but somehow Pfizer and Moderna are finding ways to circumvent reporting events as they should be reported. And you got that from the dirty beaker. So the next slide, we talk about safer vaccines to come. So we don't recommend any of the vaccines that are out currently. But like we said before, if you were to take, you really feel compelled to take one immediately, we would suggest still to this day, Johnson& Johnson. Would we take either one? No. But here are other vaccines that will be coming out to the market that we think that would be safer. They were more of the traditional vaccines that have been utilized in hepatitis B, rubella, vaccines that we've had in the past that we've been able to survive quite uh, fine with. And we find those, I have one name here, inactivated virus technology. That's where you allow for the virus to be weakened and you inoculate patients with that, and the patient develops a natural immune response to that. And we find that to be uh, better because there are parts of the virus that the spike protein doesn't account for. There are there are 4 to 5 proteins that are very specific. We call the COVID vaccine a men's virus because they have the M spike, the E spike, the N spike, and S spike. You can't make this stuff up. And so those are the proteins on the coronavirus, and those proteins are also important. So when you mount an actual response to all of those proteins, you have a better chance to mount an immune response, a more accurate chance as well. We also look at the protein technology. Cuba has a vaccine that is coming out, and it's very interesting because Cuba uses a protein and they utilize yeast in order to grow this recombinant protein, which makes it much safer. It's a recombinant protein. Recombinant protein has been utilized, like I said, in hepatitis vaccines and numerous vaccines that we've been using in human nature for a very long time. The interesting thing about the Soberana vaccine is that it will be available if you travel to Cuba. They're going to offer it to people that travel there, and they give you the shot, and you can. It's 2 shots to it, and they will even give you the second shot to take back with you, so you don't have to stay in a hotel and quarantine. You can have a vaccine while you're there, and you can take it when you go back. It's something to consider when there are government officials, and we're talking about these COVID and vaccine passports. We have to start considering other places that have other vaccines in the world. The United States is not the only place that makes vaccines. Cuba is one. They're making Soberana, and they have 4 more that they're making as well. The other one that I like to talk about is the one from Baylor College of Medicine. Baylor just won the national championship in basketball. I hope everybody enjoyed that. But Baylor has connected with Dinovax and Biological E. Biological E is out of India, and Biological E and Dinovax have come up with a vaccine that is more tried and true. Is a recombinant protein DNA. It also utilizes yeast as the vector to grow the recombinant DNA, and we find that to be much safer. They are in phase 2 trials, and they hope to actually get emergency use in India by the summer, the end of the summer. And I would imagine that that would be available to the United States very, very shortly. So we say this to say that, again, when we first came out with these series, the propaganda in the United States was saying that there was the vaccine. Are you going to take the vaccine? And it was only Pfizer at first. Then it was Moderna, or vice versa, Moderna then Pfizer. And then AstraZeneca came out. We want the take home message to be that there are other vaccines that are coming out that will be safer. Thank you for that next slide. There are 52 in phase 1. There are 37 in phase two. There are 23 in phase three. There are 5 authorized, 8 approved, and 4 abandoned. So please do not think that you only have to take one type of vaccine. There are many types of vaccines. Please continue to ask me and any in your personal physicians what vaccines are available and what vaccines will become available, and even ask them whether you can have an antibody titer test to determine whether you have been exposed to COVID in the past before or not. And if you have been exposed to COVID in the past before or not, maybe you could hold off from taking a vaccine, because even with the vaccines are not a cure. The vaccines will still require for you to have booster shots each year. They're going to be saying that each year. And we don't recommend having a booster shot with the foreign substances that are involved with the messenger RNA vaccines that are on the market. I will on the next series talk about Novavax as well, because Novavax will be coming out soon. They do have a protein-based vaccine. I don't. I like the concept of it, but they still use a lipid nanoparticle that they place the M spikes that they develop the recombinant protein. So a lot of their process is good, but they still use the lipid nanoparticle to place like we used to play jacks, and you have the spikes coming out of this middle section. The middle section that they utilize was or is the a lipid nanoparticle. And we find that problematic because the macrophage will engulf it. And as you engulf the macrophage will eventually have to go to the spleen, be eliminated in liver. And then a lot of these lipid nanoparticles will remain in those areas. And then also, when you look at messenger RNAs, some of the protein that are created will be secreted, but some could remain in the plasma membrane. So we don't recommend it, especially having booster shots each year for those. We recommend the weakened virus technology, and we also recommend some of the recombinant protein technology. So that's what I have to say about that. Do we have another slide, Dr. Solomon? Okay, so on the next slide, there's you can see there's just a host of inactivated virus technology that is being used. A lot of this is coming out of Beijing, coming out of China, and coming out of India, which is we find to be great technology, and they're taking the right steps to make sure that this technology is working and is effective and is safe. Next slide. This one, again, this talks about Novavax, which is in phase three that will be coming out very, very shortly. And we will probably do a full series on that one when it comes out. But I just explained a bit about what that vaccine does. Next slide. Okay, so I don't think I need to go into any of that. This is just a live attenuated vaccine. So, in closing, I just like to say again to have a take home that our immune response that we mount on our own is still available to us, that allows for us to fight off viruses. We are not anti-vax. We do feel like vaccines could be very instrumental in curbing the COVID virus, not only in the United States, but globally. But we also think that contact tracing is extremely important. We also think that socialized medicine and pushing our governments to move toward valuing our us as a human population, to provide medical care for us so that we don't have the exacerbated symptoms from COVID, which is very important. And we also feel that better testing is extremely important. And that better testing has to do with PCR testing, but also antibody testing and T cell testing to determine whether we've already mounted an immune response to the vaccine without immediately telling somebody that they need a vaccine and they've already mounted an immune response to it. So I hope that everyone has gained some good information from this particular presentation today, and we'll continue to come back to you with more and more. From our hearts to yours, we do this with love and gratitude for the people that we serve. And thank you for listening.